Hello everyone, myself Piyush and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Nosai. And the name of subject is Power System Planning and Design, which comes in 4th year, 8th semester. Right now we are discussing the chapter number 1, that is Transmission Line Design, and this is the module number 3. So let's begin with the phenomena of corona. Today we are going to discuss the phenomena of corona. So for an overhead transmission system, atmospheric air behave practically like a perfect insulator, right? So no electron, or we can say as no current is going to flow from the atmosphere, right? When the potential difference between conductor is small, so if we have two different conductor, and if its potential difference between these two conductor is very small, at that time no current is going to flow from conductor A to conductor B, right? If we increase the voltage, okay, right now we are increasing the voltage of that conductor, there is a corresponding increase in the electric field intensity. We already know, because if we are going to increase the voltage of the both the conductor, at that same time the electric field intensity of the conductor is also going to be increased, right? So if air is subjected to a uniform electric field intensity of peak value less than 30 kilowatt per centimeter, you need to remember this term. If air is subjected to a uniform electric field intensity of peak value less than 30 kilowatt per centimeter, flow current between conductor is negligible. Okay, so this is the limit where we can neglect the current between these two conductor, or you can say the electric field intensity is within the limits. But when the electric field intensity increase and reach this critical value, that is 30 kilowatt per centimeter, air ionizes and become conducting. So after the value of 30 kilowatt per centimeter, the air surrounding the conductor get ionized and become conductive. This breakdown accomplished by the following phenomena. So now we are going to see some of the phenomena that are hissing noise produced, then after a faint pale yellow glow appears which is visible in dark, okay, which is visible in dark. Production of ozone gas, then after radio interference occurs, and there is loss of power. So all these phenomena occurs when we say corona is produced in tram. Okay, whenever the hissing noise is producing surrounding the conductor, at that time we can call it as a ionization of air, or we can also call it as a corona loss is produced at that conductor. Or we can see the pale yellow glow appear, that is visible in dark. As you can see over here near the guard ring, we can see the glow that is going to be appeared, and which we can observe in the dark. And ozone gas is also produced surrounding the conductors. Okay, and radio interference is occurs. So if we are talking in radio, or we can say we are receiving some signal from the radio frequency, it is also going to be disturbed. Okay, and the major part, that is the power loss in the main transmission line. This is the edited image of transmission line, where we can see the corona loss is occurring. Okay, so we can also say that air is going to be get ionized if we exceed the voltage level above the 30 kilowatt per centimeter, that is the ionization position. Okay, now we are going to see the theory of corona formation, how corona is going to be formatted. Okay, the phenomena of corona is ionization of air surrounding the power conductor. We already know how we are going to ionize our air. Okay, surrounding the power conductor. Due to the cosmic rays, free electrons are normally present in free space, right? When the potential difference between conductor is increased, gradient around the surface of conductor is also going to be increased. If the spacing between conductor to be large as compared to the diameter of the conductor, free electrons move within certain velocity depending on the strength of the field. Means greater the applied voltage, greater the potential gradient. We need to remember this term: greater the applied voltage, greater the potential gradient, okay, and more velocity of the free electrons. Now, due to the large velocity of electron have collide with the molecules of air because of the large velocity of the electron, and dislodged the electron from these molecules. So it is collide and dislodge the molecules, like in a nuclear power plant. We already studied in nuclear power plant that whenever electron is collide, the another electron is dislodged from that molecule, right? These produce another ion and one or more free electrons. This process being cumulative, because in nuclear power plant we have control rods. So with the help of control rods we can control the process, or we can say control the number of electrons that is going to be collide. But over here in transmission line we don't have such kind of control rods, so we cannot control this process. So this process being cumulative and will lead to avalanche of electrons. Eventually there will be ionization of air surrounding the conductors, okay. If spacing of conductor is less than 15 times the diameter of the conductor, the flashover will take place between the conductors, and either the corona is formed or spark take place between these conductors. So whenever we are separating our conductor, we need to mention that the conductor spacing is greater than 15 times the diameter of the conductor. If it is less than the 15 times the diameter of the conductor, the flashover may take place between these two conductor, or we can say coronal loss is also going to be produced between these two conductors, or the spark take place between these two conductors. So this term is a must remember term for all the students. Next, some of the factors that are affecting the corona loss, okay. So first of all, atmosphere. Corona formation is due to ionization of air surrounding the conductors, okay. We all know this. This is the important term, coronal formation due to the ionization of air surrounding the conductor. So corona will be affected by physical state of atmosphere, okay. Voltage gradient for breakdown of air is proportional to the its density. Voltage gradient for breakdown of air is proportional to its density. And if the weather is stormy, then number of ion may be more than the normal corona. Then the normal corona may occur at much less voltage compared to the fair weather. So if the we can say humid weather, the weather is humid weather, at the same time the ionization, or we can say number of free electrons are more than the fair weather, right? So at that time, at a lesser voltage level, the ionization of air may be occurs and corona may be formed at a lesser voltage level, okay. Corona loss is affected by the atmosphere. Then conductor size. Corona is affected by shape and condition of conductor, and also by size of the conductor. So corona decrease with increase in diameter of the conductor. So the surface area of the conductor is going to be increased, and the electron is not going move from conductor to atmosphere easily, because it have a large amount of area to move in conductor. A stranded conductor have more corona than the solid conductor, because unevenness of surface decrease the value of breakdown voltage. So in stranded conductors which has irregular surface, corona effect is more pronounced. The effect of dirt on the surface is to increase the irregularity, and by this breakdown voltage decrease, so corona is increases. So if we are using stranded conductor, at the same time the more corona loss is produced as compared to the solid conductor, because the unevenness of the surface conductor areas. And if there is dirt on our surface area of the conductor, at the same time corona loss is also going to be increased, because the breakdown voltage is going to be decreased, okay. Next term, that is the line voltage. So corona loss is also directly depend on the line voltage. So corona is directly affected by the line voltage. At a low voltage there is no corona effect, but when the line voltage increase, then electrostatic stress developed at conductor surface makes the air surrounding of conducting and which lead to the corona formation, because ionization, it is going, if we are going to increase the voltage level, the air surrounding the conductor is going to be get ionized and the corona loss is formation. Okay, next we are going to see the spacing between conductors. So spacing between conductor affect the corona formation. If spacing between conductor is increased, then electrostatic stress are reduced. Okay, if we are increasing the spacing between conductors, we already know about that. If the spacing between conductor is less than 15 times the diameter of the conductor, at a time coronal loss is going to be increased or flashover may occurs, right? So if we are increasing the spacing between conductor, we can say that electrostatic stress is reduced and corona loss effect is also reduced. If spacing between conductor is made very large as compared to that diameter, then there may not be any corona effect due to the reduce in electrostatic stress. So we need to separate our conductors as far as possible, but within the consideration, right? Within the consideration of cost, or we can say in economical aspects. Now we are going to see the advantages and disadvantage of the corona. So here are some of the advantages and disadvantages. A few years ago, corona was considered as something to be avoided because of energy loss in it and distortion of waveforms. Okay, but nowadays corona is considered as advantage because it has following benefits. So corona have some amount of benefits. So which are they? The benefits are like, owing to corona formation, air surrounding the conductor become conductive and there is virtual increase in conductor diameter, because if we have this amount of diameter of the conductor and corona is formation like this, so the overall diameter of the conductor is going to be increased, where the free electron can be travel, right? So the overall diameter is going to be increased. Due to this, the electrostatic stress is reduced between the conductor, so probably of fast over is reduced and system performance is improved. Okay, next, effect of transient produced in lightning surge and other cause are reduced because of this corona loss, and charge induced on the line by surface will be partially dissipated as a corona loss. Okay, in this way, it is act as a safety value. So corona may benefit our transmission line sometimes. Now these are the disadvantages. Following are the disadvantages. There is a loss of power more pronounced at abnormal weather condition, which affect the transmission efficiency, because corona is ultimately one type of loss, so it is affecting our transmission efficiency. Next, due to the corona formation, ozone gas is produced, which chemically react with the conductor and cause the corrosion. Because of the formation of ozone gas, the conductor is going to get corrosion. Okay, so this is second disadvantage. And third one, that is due to non-sinusoidal corona current, there is non-sinusoidal voltage drop, which cause comes interference with neighboring communication circuits due to electrostatic and electromagnetic induction. So it is going to affect nearby communication circuit. And fourth one, that is owing to distortions of waveform, harmonic are introduced into the transmission line. This harmonic increase the corona losses. Okay, so harmonic is also increase the corona losses. That's it for the today's lecture. If you have any kind of query regarding this module, then you can ask me in comment section. Thank you.